folks, let's get into our last structural classification of joints, and that's going to be synovial joints. Now, synovial joints is going to take us through the rest of the entire, or majority of the rest of the entire lecture, because once we learn the basics of synovial joints, we're then going to get into their movements, and then finally, at the end, we will talk about disorders of joints overall. Now, most joints in the body are classified as synovial joints. And these are going to be the joints that folks remember the most because it has to do with the shoulder, the elbow, the knees, the knuckles, and the hand. And one thing we need to understand is that a lot of synovial joints are going to have dynamic or free movement. And so they are going to be a part of diarthroses. So they do have that ability to be able to move around more freely. Okay. Now remember, because there's more movement, you're going to have less stability, and with less stability, you're going to be more prone to injuries or like dislocations or something like that, okay? But it is going to be important to know that all synovial joints don't have this the same type of movement. So not everybody's just like, oh, a large amount of movement. Some may have less movement, and we'll see those different types as we go along. Okay, so you might be saying, well, how do we help these joints out if we know that they're more prone to injury or dislocations? Well, that's going to bring us to the unique characteristics of synovial joints. And so these unique characteristics are going to make the synovial joints a bit more stable so that you're not just walking around moving and then breaking, dislocating your shoulder every time you move it around, right? No, we have different things, and we saw before, like our muscles, our tendons, our ligaments, etc. That's going to, and of course, the synovial cavity is going to help stabilize our overall synovial joints. So a synovial cavity is simply just a space between bones that stores synovial fluid. So that's one thing we want to understand. Now, what is the synovial fluid? It's very viscous, so that means it's very thick liquid that's serving as a lubricant and a shock absorber. So inside of this actual synovial cavity, we have that synovial fluid. And that's really going to help us be able to have smooth movements and to protect joint components. Okay? We also have articular cartilage. And we've seen articular cartilage before. That's going to be our hyaline cartilage that is going to cover the end of bones, and of course, the ends of synovial joint bones. And what is the purpose? To reduce friction. Okay. There's also something called the articular capsule. That's going to surround the joint, and it's going to have two layers that are going to be surrounding the joint. First is going to be the inner layer. That's going to be called the synovial membrane. That's again going to line the synovial cavity and also is going to produce that synovial fluid. So that's definitely an important inner membrane. And then we have an outer fibrous membrane, and that's going to be good old dense, irregular connective tissue that, again, is going to be on the outside of the actual synovial cavity and therefore the bone. You can also think of it as just a thickened continuation of the periosteum or the outermost layer of bone. If we're going back to understanding bones, we know we have the periosteum is going to be around or covering the bone. And you can just say that that's going to be the continuation of that periosteum. That's going to allow for flexible movement and make the actual joint more stable. One thing that's not here is that, of course, our synovial joints do have ligaments. Remember, that's those band of connective tissue that's going to reinforce joints for stability. It also has blood vessels. The blood vessels are going to nourish the synovial membrane, and of course, that membrane is going to help produce that synovial fluid. And it also has innervation, so it has nerves. And that's going to help with pain and understanding position of movement. So remember, if you think of like something like proprioception, then you might be saying, okay, how do we understand our place, our body's place in space, or how we move in the world? Well, there's going to be nerve signals that are going to be doing that, and they're going to help send different types of signals, or receptors are going to send signals to the brain and say, hey, here's the angle that our shoulder joint might be in. Here's the angle that our knee joint might be in. And that's going to help us figure out the position that we're in and also the type of movement that we're making. Get ourselves oriented. So as you can see, we are going to be calling out a synovial joint in between our actual phalanges here. Okay. So again, we have our bone here and we have bone here. The easiest thing to see is that synovial cavity and its fluid. That's going to be all the pink here. So here's our cavity here. This is all our cavity. Okay? I just want to call that out just so I can show you. Then we can all easily identify the articular cartilage because that's going to be the cartilage at the end of bones. So here's our articular cartilage. Next, we're going to look for the inner synovial membrane, Remember that inner synovial membrane is going to help produce the synovial fluid. So all this excess fluid here is going to be produced by the inner synovial membrane that we see here. Let me erase the cartilage. So all that fluid here is being produced by the inner synovial membrane. And then we have the outer fibrous layer. Remember, the outer fibrous layer is made of dense irregular connective tissue. And that dense irregular connective tissue is going to resist force in multiple directions. There's no particular pattern, so it can resist all the excess force from all these different directions, will make it, again, more stable. Okay, so that's the outer fibrous layer here, and you'll see that here, outer fibrous layer. And again, it's kind of a continuation of the periosteum of the bone and stuff. And then finally, you have ligaments, which are going to reinforce the joints for stability. And here's our ligaments that are connecting bone to bone. So again, more bands of connective tissue that are connecting the bone to give it more stability. Okay, and so these are some of the unique characteristics that we see in all synovial joints. Now let's get into some characteristics that are in certain synovial joints. But before we do that, let's talk a little bit more about the synovial fluid and see what its importance is going to be. Now, synovial joints have the ability to have synovial fluid within them, that viscous, thick fluid that's going to help, again, with lubrication and be a shock absorber to allow us to have smoother movement and to protect the joint components. Okay, so we do have an idea of weeping lubrication of synovial joints. Weeping lubrication is just basically a process where synovial fluid in the articular cartilage is forced out upon compression. So that means when you are walking, or specifically you're running, the synovial fluid is going to be forced out of the actual cavity. And we'll talk about what happens when that, we'll talk about the details of what happens when that. Now, when the pressure on the joint is relieved and you're back to kind of relaxing, that's when the synovial fluid is going to soak back in to the actual cavity, like you're thinking water into a sponge. And so there is a connection between that synovial cavity where the fluid is and the articular cartilage. And one of the main things that's going to connect them is that when you actually have the articular cartilage right next to that synovial fluid, it can nourish the articular cartilage and nourish the chondrocytes within that cartilage as well. Okay, so let's kind of have two different things. When you've got a relaxed knee joint and when you have a compressed knee joint. Here's our example. So when you have a relaxed knee joint, as you can see, we have our synovial cavity here, we have our inner membrane, we have our articular cartilage. That's what we're focused on. And that means that some of the fluid, synovial fluid, can actually soak into the articular cartilage. That's what we're talking about, kind of like water soaking into a sponge. That's the example. And as it soaks into that articular cartilage or hyaline cartilage, it's going to nourish all of the chondrocytes within that cartilage. That's what happens when you're just chilling out and relaxing. Okay? Now, another way you can say it is the articular cartilage is absorbing synovial fluid. It's not absorbing all of it, right? It's continually to be processed to have synovial fluid in that cavity, but it can be absorbed to help get some nutrients from that synovial fluid. Versus when you are running, you are compressing the knee joint. So if you're compressing it, that means synovial fluid is going to be forced out, okay? So you're running and you're going to be, again, compressing that synovial joint. And what's going to happen? The articular cartilage is also going to be compressed. And you don't want bone on bone, which is why you have the synovial cavity filled with that synovial fluid. But what's also going to happen? That synovial fluid is then going to be forced out. And because it's being forced out, it's going to actually act as a lubricant and shock absorbent to protect that articular cartilage from, of course, hitting one another and, of course, in causing some kind of bone-on-bone friction. Okay? Yes, the hyaline cartilage on its own is going to actually have some type of ability to reduce friction and make things more smooth. But when you have this amount of force, when you're actually running or something like that and causing that much compression, you do need a lot more help. So that synovial fluid is going to kind of like, of course, leak out. It's going to be in a shock absorber because it is thick. It's not some kind of thin fluid. And again, it will lubricate the areas around to protect the articular cartilage. So that's just one thing that we say is like weeping lubrication of synovial joints. So when the joint is relaxed or when it's compressed, you'll see exactly how that synovial fluid works. Now let's look at some other additional features in some synovial joints. So it's not in all of them, it's just in some of them. The general features we saw before, that's going to be in all of them. These particular features are only going to be in some of them. So first is going to be the bursa or bursae. These are going to be synovial fluid-filled sacs. What is their goal? to reduce friction between ligaments and tendons and other tissues. And one thing you also see is the tendon sheath, which is basically an elongated bursa that wraps around and protects a tendon, thereby reducing friction. So remember, a tendon is going to connect bone and muscle to one another, or muscle to bone specifically. And when you have a tendon sheath or elongated bursa wrapping around it, that's going to help reduce friction between the muscle and the bone. Okay? So bursa is going to be, again, synovial fluid-filled sacs. Now, we also can have fatty pads, and these are usually present in the knee and hip joints. And what is this going to do? Provide cushioning. Going to provide cushion between the fibrous layer and the synovial membrane. More cushion, again, providing more stability. Bursa, we're thinking, okay, especially with the tendon sheath and just the bursa in general, yes, it's going to help reduce that friction. And what is it going to do? It's going to help prevent damage. So, of course, you are pulling a ligament or you're stretching a ligament too much, for example, or you're stretching a tendon too much. There are going to be those, some of them will have those tendon sheaths or the bursae around where those ligaments and tendons are to help make sure that we prevent damage. Now, when you're talking about fatty pads, that's going to cushion between the fibrous layer and synovial membrane, we know that that's going to be very important because for some areas, like again, our knee and our hips, you're bearing a lot of weight on those joints. Because of that, you're going to need extra layers for stability. So it's just not only the synovial fluid that's doing all the work. Okay? Next, we have articular disc or meniscus or menisci, which is going to be the plural form. And this is going to be disc of fibrocartilage or fat that divide the synovial cavity into two so that it has better shock absorption. Okay? And this again is present in the knee, our jaw, and some other joints as well. Now, why would this be important? Well, think about it. Every time you're like, oh, they have a torn meniscus. Yes, that means that they're going to have a lot more issues and a lot more pain while walking because they won't have the ability to absorb extra shock because we're kind of breaking our synovial cavity in two. Okay? So just keep that in mind. Here's a visual. We have the shoulder joint and we also have the knee joint. Both are going to be synovial joints. Now, they do look a little bit different. So let's see. First things first, let's look at the shoulder joint. We do see ligaments here. We see a bursa that's going to be here as well. And what is that bursa's purpose? To reduce that friction between that ligament. Okay? And of course, its relationship to the rest of the joint. We also have a tendon sheath. So we know a tendon is going to be connecting muscle to bone. And that means that's going to be a bursa wrapping around that to help reduce friction as well. And of course, here's a tendon here. Here's a ligament here. Okay? And that's going to be the main kind of additional features you see for the shoulder. Let's talk about the knee. The knee has way more of these additional features. So first, it's still going to have bursa. So you can see you have bursa here, right next to the patella. We have bursa behind, and front. Everything that's purple here is going to be our bursa. We also have fatty pads. Again, that's going to allow us to have that extra layer because these are load-bearing joints. And we have the articular disc or meniscus that's going to separate the synovial cavity in two. Remember, if you have a torn meniscus, you don't have the ability to divide that synovial cavity, you don't have the extra shock absorbers, and it will disrupt that knee cushioning, as we see in this example. And if it disrupts the knee cushioning, it's going to cause less stability, and that means you're going to have pain and joint damage. Okay? So that's kind of the idea behind synovial joints. You want to know the overall general features. You also want to know the additional features that we see here. You can also go to your textbook to see different visuals of what the synovial joints look like. So again, we have our synovial cavity here. We can see our articular cartilage. We also can see ligaments here. And again, we can see our different types of membranes, our outer fibrous membrane, our inner layer as well, our synovial membrane. And then it shows like different bursa in between ligaments here in the shoulder here. And then we also see another version of a bursa fluid-filled sac that's going to decrease friction and ligaments as well. Just kind of a more illuminated piece. So that's what you want to kind of focus on if you're thinking maybe the visual that you see here, you want to be able to see it in a different way. That's what you want to focus on. In our understanding of synovial joints, I do want to focus on the fact that synovial joints have a lot of movement, meaning they have less stability. And we saw all these different unique characteristics like the cavity, et cetera, that's going to help with keeping the actual synovial joints stable. But there's going to be three main factors that help prevent that dislocation from happening in general. First is going to be the articular surfaces. Yes, they have a minor role, but you can have shallow surfaces that's going to be less stable. Think about the humerus and the scapula. Remember we have that glenoid cavity, and we said that it allows for the humerus to have more movement. But again, because there's more movement, it's going to be less stability. Whereas a ball and socket, like we saw with the femur and the hip bone, we definitely saw that that's going to be more stable, even because it had a deeper depression that we saw there, right, with the acetabellum. So just keep those little details in mind. But overall, the shape of the articular surfaces will play a minor role. Now let's talk about something that's going to play more of a limited role, which is going to be your ligaments and the location of those ligaments and the amount of ligaments. So what are ligaments? We know that they're bands of connective tissue that's connecting bone to bone. So the more ligaments you have, the stronger the joint, because that's going to help stabilize those overall, that connection between bone and bone, and then stabilize the overall synovial joint itself. Okay? And then finally, the most important is going to be muscle tone. Why is muscle tone important? Because it's going to keep the tendons taut across joint. And remember, tendons are going to connect muscle to bone. So we have to make sure those tendons are actually working properly. Even if you have the tendon sheath or the bursa surrounding the tendon, you still want to make sure your tendons are actually working properly. And that's going to help you create more stability, mainly in your shoulders, your knee, and your foot arches. Okay? And remember, the knee is going to be important because it's also low bearing. So it has a lot of weight attached to it. Having the muscle tone around the knee is just going to keep those tendons connected. You will have less tears and less pain. All right, folks, I'll see you in the next video, which is going to be all about movement of synovial joints.